Hi everyone. Today I'm going to solve the problem 3.39 in the textbook. Tom is climbing a 3-meter long ladder that leans against a vertical wall contacting the wall 2.5 meter above the ground. His weight of 680 Newton is a vector pointing vertically downward. What are the components of Tom's weight parallel and perpendicular to the ladders? So I draw a picture of the problem like right here, which is the height of the wall is 2.5 meters and the length of the ladders is 3 meters. The weight of Tom is 680 Newton and pointing vertically downward. And I mark the angle theta here, and I'm gonna find theta later. So I also have the free body diagram right here because the motion is pointing vertically downward. So the friction is going opposite and is negative side. And we also have the normal force points upward, positive direction, and the gravity point downward and is not belong to any y or x-axis, so we need to decompose the vector of the gravity. So I have fgy here and fgx here. Fgy is pointing to the opposite, so it's negative side for fgy, and fgx is pointing to the positive direction, so it is a positive side for the fgx. So let's determine the components of Tom weight parallel and the perpendicular to the ladders. So Tom weight parallel to the ladder is the vector g of x. Yeah, you see, parallel to the ladders. And Tom weight perpendicular to the ladders is fg of y. Yeah. So how we can find fg of x and fg of y? So let's move on. So I have the gravity force analysis here. So fg of x equal fg sine of theta, and fgy equal negative fg cosine of theta. So that right here, f sine theta. Just remember the negative side. Oops. Yeah. And to find the value of theta, let's review some trig identities. So according to the formula, we have the sine of theta equal the opposite over the hypotenuse, and which is equal to 2.5 divide 3.0. And to determine the value of theta, we can use the calculator to solve for it. So, but make sure your calculator is in degree mod. Like you can put the button shift mod 3 and then input shift sine 2.5 divide 3, and then you got the answer approximately 56.4427. And just plug in the data and then we can find out the answer. So the components of Tom's parallel to the ladders is the value of fg of x, which is at the gravity force multiplied sine of theta, and we got 680 sine 56.4427, which is approximately 566.6667 Newton. And we're doing the same for the component of the perpendicular to the ladders, which is fgy equal negative fg cosine theta equal negative 680 multiply cosine of data, and the answer is approximately negative 375.88 40 Newton. I think there is another way to solve for the problem. Instead of find out the value of theta, you can use the Pythagorean formula to solve for the adjacent here, and then just find out the sine and the cosine, and then I think you also get the same answer for this problem. So if you are interested in doing the other way to solve for this problem, you feel free to email me if you have any question about it. Thank you. So this is the whole work of the problem. You can take a picture. Yeah, that's it. Thank you.